Welcome to the ADP training simulation. Today, you'll learn about wafer lamination, dicing, die bonding, wire bonding, and inspection. The in-world checklist shows each step of the process. Let's begin with the first station. Wafer lamination using the Model 3100 film applicator. In the first step of wafer lamination, we use the Model 3100 film applicator to prepare wafers for the delicate process of dicing. To begin, a metal ring is positioned to frame and support the wafer. Next, the wafer is carefully aligned using the guiding lines to ensure cutting accuracy. A stretchable film tape is then pulled across the wafer's surface. This film will hold the individual dies in place during cutting. A roller is used to press the tape firmly against the wafer, ensuring a smooth, secure bond. A rear blade slices the back of the tape, and pressure is applied at the center to lock everything in place. Another blade trims the tape around the ring, creating a clean edge. Any excess tape is peeled away and discarded. Then, the entire setup is flipped. The applied tape is heated to activate its adhesive. Just 1 minute is enough, but longer improves bonding. Once finished, the wafer is removed and allowed to cool before it's ready for dicing. This concludes the film application of the wafer. The dies are now secured and ready for cutting. Now, let's move on to the next step of the packaging process. Wafer dicing using the ADT dicing machine. This is the ADT dicing saw. It is essential for precisely cutting silicon wafers. Now, let's take a closer look at it in action.
Welcome to the dicing simulation. In this interactive simulation, you will learn how to use the ADT 7100 dicing saw, a powerful machine used to cut semiconductor wafers into individual dies. Dicing is the process of cutting a semiconductor wafer into smaller, functional pieces, called dies or chips. These dies are then packaged and assembled into the electronic devices we use every day, like smartphones, computers, and medical equipment. Here are the steps for dicing a wafer using an ADT machine. 1. Prepare and mount the wafer. Clean the wafer and mount it on a dicing frame with dicing tape. 2. Set up the ADT machine, install the appropriate blade, dress it if needed, and secure the wafer on the chuck. 3. Program and align. Input cut parameters, die size, depth, speed. Align the wafer using fiducials or camera. 4. Post-dicing handling. Inspect the dies, release them from the tape, UV or heat, clean, and sort them. Please open the ADT machine, pick up the wafer from the table, and place it on top of the highlighted vacuum chuck. Click on the highlighted section of the machine to open the second compartment. Now let's learn about the saw. The saw in a dicing machine is the core component responsible for cutting wafers or materials into smaller pieces, known as dies or chips. It consists of a high-speed spindle that rotates a precision diamond blade. This blade makes extremely accurate and clean cuts, often down to micrometer-level precision. Not all materials can be cut with the same blade or saw setup. Materials like silicon, sapphire, epoxy mold, and ceramic each have unique hardness and thickness. For best results, the blade type, bond matrix, diamond grit size, and spindle speed must match the material. To the left of the ADT machine, on the wall, there is a chart showing the correct settings for each material. Loading the correct recipe is essential because it sets the cutting parameters specific to the material and ensures precision and safety during the dicing process. Without the right recipe, the blade may damage the wafer or produce low-quality cuts. Click on the monitor to watch a short video demonstrating this process.
Now let's load a recipe. Let's pull up the recipe editor. We're going to pick a silicon 10 by 10 millimeter 500 micron wafer and load it for dicing.
You can refer to the ADT Standard Operating Procedure file for more detailed information on how to set up the parameters. You may get closer to the ADT machine to have a better look at the dicing process. The wafer will now rotate 90 degrees and the dicing process is repeated. Well done. You have almost completed the dicing process. The dicing process is completed. Open the front cover and pick up your wafer. Above the ADT machine there is a picture of a diced wafer. The next step in the packaging is die bonding. You will go to the die bonding simulation and learn more.
Now that you've learned how to dice the wafer, let's move on to the next step, die bonding. This is the Tresky T3000 flip chip bonder. It bonds the die onto the chip package. Now, let's take a look at how it works.
Welcome to the die bonding part of the chip packaging process. In this simulation, you'll perform key steps to accurately place and bond a die, chip, to its base using a digital replica of a die bonder machine. In this simulation, you will learn how to perform die bonding using the Tresky machine. Here's what you'll do. 1. Watch a setup tutorial to understand how to control spindle force and timing. 2. Place the die and base on the appropriate sections of the slider. 3. Control the spindle to pick up the die and align it with the base. 4. Use the camera system to check alignment and watch a short instructional video. 5. Apply epoxy to prepare for bonding. 6. Lower the spindle to press the die onto the base, then lift it. 7. Place the bonded chip into the oven to cure. Now, let's learn about the equipment required to perform die bonding. First, we have the Tresky die bonder, which is the main machine you will be working with. It is responsible for picking up the die, aligning it with the base, and pressing it into place. You will be using it to control the spindle, move the slider, and make sure everything lines up just right. Next, there is the alignment camera system. This is built into the Tresky machine and helps you see close-up views of the die and the base. It is important for making sure the two are perfectly aligned before bonding. You will be able to switch between views and check your positioning on the screen. Now let us talk about the die itself, that is the small chip you will be bonding. It is a piece of silicon cut from a larger wafer, and it contains the actual circuits or components. You will be placing it on top of the base during the process. Speaking of which, the base, or substrate, is where the die will be attached. This can be a lead frame, a small metal plate, or a special board depending on the application. It supports the die both physically and electrically. To attach the die to the base, you will use epoxy. This is a thermally and electrically conductive or insulating adhesive that gets applied to the base before the die is placed on top. Once the die is in position, we press it down and then cure the epoxy using heat. That brings us to the oven. After the die is bonded to the base, you will place the whole unit into the oven. The heat cures the epoxy, making the bond permanent and secure. After a few minutes, the product is ready and fully bonded. Congrats! You got it right. On the Tresky machine, click on the bond force control shaped like a mini-boxed computer on the left side of the Tresky machine, to watch a video that shows the process of setting up the time and force.
Here we have the Tresky program editor. we access it by touching Menu. Here's the Force menu where we set what force to pick up our part or to bond it at. To modify a setting, we tap Menu again and use the up and down arrows below to change values. The Time menu allows us to change the timing that the machine picks and places. The Height menu allows us to edit the height that we pick up a part, where the part comes down into focus on the camera system, and the height that it places the part at. Puff time is generally not used, only for advanced settings. The Speed menu influences how fast the parts are picked up and placed. The Eutectic menu allows us to operate the heaters either with a quick heat pedal or with confirmation when the part is placed.
Great job. Now pick up the die and place it on the highlighted part of the Tresky machine. Now pick up the base and place it on the highlighted part of Tresky machine. Great job. Now move down the spindle to start picking up the chip. Well done. Move the base under the spindle. You can click on the highlighted part of the Tresky machine to move the base. Alignment is one of the most critical steps in the die bonding process. When placing the die onto the base, even the smallest misalignment can cause serious issues later. You will now watch a short video of this process. Click on the highlighted knob on the camera system. You can see the camera in action. Great work so far. Epoxy is important because it holds the die firmly to the base, creating a strong mechanical and thermal connection. It ensures the die stays in place and can handle heat and stress during use. Now grab the epoxy and add some to the base. Almost there. Open the oven, then pick up the assembly and place it into the oven. Well done. Now open the oven assuming that it was closed for 5 minutes. Well done. You have completed the die bonding process. Now let's take a quick quiz to check your understanding.
What does the alignment camera help you do? Why is the oven used at the end of the die bonding process?
Well done. You answered all the questions correctly. Now we will move to wire bonding simulation.
Now that you've finished die bonding, let's continue to the next step, wire bonding. This is the F and KM17L wire bonder. It's used to connect the silicon die to the chip's pins. Let's see how it works with some on-hands training.
Welcome to Wire Bond Training. This VRS is to train technicians on chip-scale packaging. There will be 3 main tasks to learn within a total of 13 steps. The tasks are to first do 2 types of alignment, first for the package then for the chip. Second, execute single wire bond to test wire. Then, auto bond the rest of the multiple wires. Third, inspect after each bond is executed. Each step and its purpose will appear in a pop-up. Sub-steps for each step will appear as a checklist to guide trainees. Are you ready to start learning? Step 1 13th. Wear protective gear. Step 2 13ths. Learn wire bonder, Delvotech, equipment parts. Step 3 13ths. Chip setup. Step 4 13ths. Ready wire bonder equipment. Step 5 13ths. Pattern recognition software. Step 6 13ths. Load pattern recognition software. Step 7 13ths. Package registration point align, 1/2. Step 8 13ths. Registration point align 2/2. Step 9 13ths. Execute single wire bond. Step 10 13ths. Single bond inspection. Step 11 13ths. Execute auto bond. Step 12 13ths. Auto bond inspection. Step 13 13ths. Send wire bonder home. Begin by wearing safety gloves, glasses, and a TVEC suit. In that order. Great! Now that you are wearing your gear, we can proceed. First, we need to learn about the different machine parts. The monitor is where you will load precise pattern recognition software, adjusting and aligning patterns on screen, and execute wire bonds to secure connections between semiconductor components. Next, the XY arm moves along 4 different axes: the X, Y, Z as well as theta rotation for the bond head to create wire bond connections between the plate and chip. The base plate will hold and secure your die-bonded chip on package during the process. This keyboard is where you will prepare the wire bonder and load correct recipes, ensuring all settings are correct. To move the XY arm, you can use the trackball. This is very important for aligning patterns. Get started by placing our die-bonded chip on the base plate. Perfect. Ready the machine with Adjust key. Great job. Now load your registration pattern with Enter key. We'll first align the package, then the chip registration points. An alignment step is for the equipment to use a predefined registration markers to accurately orient its respective physical target. Notice on your monitor a list of patterns to run. I have pre-programmed a pattern recognition software and configured it to your chip's patterns for us to use today. Taking a look at the left side of the monitor, we have Load Program. A folder of different registration points. The one we will be using is highlighted. On the right side is the loop parameters. The red outline represents our wire loop and below are the loop parameters. Key loop parameters include loop height, length, shape, wire diameter. Now run the program using Adjust key to load your patterns into the wire bonding OS and prepare to align die-bonded chip on package. First, we will align the patterns on the package. The upcoming monitor will show the camera display on the bonding head as well as the pattern from our loaded software. The registration point from our loaded software for the package is the yellow outline. It must align with the package contact that aligns a gray triangle. We can see the patterns are not correctly aligned, so we will move the XY arm to correctly align them. Use trackball to move XY arm and align package patterns. Great job! You have aligned the patterns. We can see that on the monitor. Use Adjust key to switch to chip registration point alignment. Now taking a look at the upcoming monitor that will be displaying the chip's registration point, 2 crosshairs, and F character. They do not align. We will use the XY arm to align the patterns. Perfect. All patterns are now aligned and we are ready to wire bond. Wire connection is a two-step process. First, do single wire connection to verify the accuracy of the alignment, then auto bond on the rest of the multiple wires between the chip's bond pads and the package's substrate. Execute one wire bond with 2 connections between the package and chip using bond key. The bond key will only execute a single wire loop bond. Great. Now inspect the bonds using the Enter key. The monitor has changed to show you the wire bond connections. Check wire bonds on the monitor and ensure there are no broken bonds. If all connections are good, use Enter key. We see single wire bond are good. Now we perform multiple bonds using Auto Bond key. The Auto Bond key by automation creates multiple bonds. Just to be safe, inspect the bonds in using trackball. Perfect. All bonds look great. Now that all bonds are complete and we inspected all wire bonds are connected, we can send the wire bonder home using Adjust key. Please answer the multiple choice and open-ended AI-powered question to complete the simulation. Well done. You have answered the question correctly. Now, let me ask you an open-ended question. When you are ready, please click the microphone and speak your answer. An AI agent will analyze your answer and respond to you. What are the 2 steps of alignment?
The 2 steps of alignment is to align the package registration points and align chip registration points.
The response is correct. The 2 steps of alignment in wire bonding are indeed aligning the package registration points and aligning the chip registration points. These steps ensure precise connections during the bonding process. You correctly identified the 2 steps of alignment as aligning the package registration points and aligning the chip registration points. This demonstrates a clear understanding of the wire bonding process. You have now completed the VR portion of Advanced Device Packaging training at Princeton Materials Institute. Please remove your headset and proceed to inspect a chip in real life.
This is the testing board for the custom silicon production chip. This is meant to show where possible manufacturing errors can occur whilst processing the die bonds. For example, this die bonded chip has a fault in it, which this board is catching with this LED not lighting up. All these LEDs should be lit up in order, but because this chip has an incorrectly bonded pin right there, it does not. This board has 2 testing portions. It has the daisy chain test, which tests a daisy chain in sequential order, then a button test, which tests continuity between buttons. It's a relatively simple test board, and it's effective for its purpose.